All right, let's wrap this up. And here we go. All right, it says in America's Got Talent, he jumped from a tower 40 feet high. All right, first of all, simple thing I want you to do. I mean, we're in college, we can do that. How many meters is 40 feet? Okay, so calculate how many meters that is. If F equals mass times acceleration, has a mass of 90 kilograms, what is the force on his body pulling him down? The acceleration is the acceleration due to gravity. Okay, so the force pulling him down is F equals, it's basically his weight, is what we would say. Okay, that's the force pulling him down, overcome his inertia. All right, so you take, this would be take his 90 kilograms times 9.8. All right, what is Professor Splash kinetic energy when he hits the water? Assume his mass is 90 kilograms. All right, don't use a comma or scientific notation in your answer. All right, so here you go. So, what is his kinetic energy? All right, so what do we have to do? We've got to calculate his velocity. But we should switch 11 and 12. That would make it easier. My mistake. Okay, so sorry about that. We're going to switch 11 and 12. I promise that. All right, so what's the speed when he hits the water? You should know how to do that. So right now, when you guys get to a number, problem 11, it'll be speed when he hits the water. All right, so the speed when he hits the water is equal to V is equal to square root of 2gh, and you calculated the height, what 40 feet was in meters, okay? And then in your problem 12, you're going to calculate, which is actually, what's his kinetic energy when he hits the water? Okay, well, for your number 12, 11 here, but 12 by the time you get around to this, kinetic energy is equal to 1/2 times 90 times this V squared. Whatever you got, and then you square it. Or you could just put in the 2gh, that would work too. 90 times 2gh, that actually will give you his kinetic energy. Okay. All right. That works. Knowing that F equals ma and he has mass using the previous, how many g's of acceleration did the water push up? Oh, wait, we're not done. This is pure speculative, but I think the answer is, let's assume he goes 0.302 meters down, because they said he's falling into a foot of water or something like that. So 0.302 meters under the water at the end of his belly flop. Remembering that K equals F times force times distance, you've got the kinetic energy from problem 12. All right, I got to flip-flop those two again. Now, take your kinetic energy and divide that by the force that he hit the water. Okay, which you calculated is mg. So what are we talking about in problem 13 there? Problem 13, here's what you're doing. You take your answer from 12. So you take this guy, which is your kinetic energy, and you make that equal to force times distance, and the force is equal to 90 times g. And then, oh no, we're trying to find the force. We're trying to find the force that hits the water. Boom. It's a whole different ball game because now the water's pushing up on him. My bad. So you take the KE, what you got, divided by the 0.305. I shouldn't try and force these on late Friday afternoon because my brain is shot. Hopefully you're doing this when you're fresh. Okay? All right, so let's just finish this out and call it a day. All right, so knowing that okay, so you find this tremendous amount of acceleration, so now you want to calculate the g's. What you do is you take the acceleration. Wait a minute. With what force? Okay. What force? All right. So what we do here on question 14 is I'm going to throw it out. It's stupid. I don't want to do it. So, and then in question 15, starts this run, half pipe. Then they are at a maximum height, much greater height at the end, reach height equal to their starting height. Pick 15, because that one didn't make sense either. All right, so I'm going to get rid of 14, and I've got to rehash 11 and 12, and we are done.